Hey everybody, welcome to the 7th episode of the Network Automation series, and today we're going to wrap up this Network Automation lab. The goal of today is to get routing set up on this Nexus. We're going to just do a real basic static route of all zeros to the CAT AKV internet, and then we're going to do a rule that allows this inside interface to NAT to this outside interface to this NAT external connector. Now, Ansible does not have a module dedicated to setting up NAT. Even the interface configuration module doesn't allow you to set the inside-outside configurations for the interfaces. So what we're going to do is we're going to build a Jinja template. And the Jinja template is going to allow us to define the three things that we need for NAT to come up on the Cisco 8000. And what are those three things? We need to define our inside and outside interfaces, so that's one. We need to define our access list that allows this SVI subnet and this SVI subnet to reach out and actually be able to use the NAT table. And then we need to define an IP NAT translation for this inside interface to this outside interface, defining the access list that we want to use. And because we've only got this one, we're going to overload it. And basically, we're going to take those commands and we're going to put them all into this template. And I'm going to show you how to use variables so that the template can call them. So if we ever decide that we want to add more hosts or subnets to this Nexus, or if you have another lab where you start building that connectivity, you'll be able to see how to use variables to actually set up your access lists and expand it and change it without having to go in and manually make those changes in the CLI. And once we've done that, the lab will be done. We'll have routing out to the internet. We'll have routing back to our hosts. We'll also have to add a static net route here so that they know where to get to our two hosts here. And yeah, we'll be done. Like this we'll have configured this from scratch with automation, not doing anything in the CLI. I'm going to actually take everything we do today and update the GitHub repository that we created in the last episode, so you're able to work with this in the future and see everything from start to finish. You will be able to take this lab from scratch and build it out completely, and then get a really good understanding of how different things work. We've looked at show commands, we've configured system variables, we've configured interfaces, and now we're getting into a little more complex things with routing and NAT configurations. And also seeing how to use templates. So you're going to have all of that at your disposal when this is done, and we're going to hop over to Visual Studio Code now and start working on today's configurations. So we're over in Visual Studio Code now, and we've got the CML Ansible automation folder open. Now, if you recall from the last episode, this is now the folder that we're using to work with our files. This is what's bound to our GitHub repo sitting out on the internet, and this is the local instance of it running on my jump host. The cool thing here is these changes that we make today for this video are going to get uploaded to GitHub after I've made all of the updates. And one of the first updates we're going to do is we're going to create a folder inside the CML Ansible automation folder, and we're going to call it, I don't want to put it in show commands, we're going to do new folder, and we're going to call it NAT config. So this is where we're going to start doing all our NAT configurations on the device. And like always, we're going to grab a couple things here. Let's go to interface config and get host vars. Let's get Ansible config, and let's get our inventory. We're not going to grab tasks today. So we'll paste all of that inside the NAT config folder. And we see that it's gone green because the repository is picking up, the local repository is picking up those changes that are not in the remote repository sitting on GitHub. And as we start making updates, we'll see things, pop up green. We'll eventually be able to come over here and say, do we want to commit these changes? And we will be able to commit them after this is over if we choose to. So let's go ahead now. We've got our host vars, we've got our inventory, we've got our Ansible config. Let's create our first new folder today, and we're going to call it templates. Now, because we're doing Jinja 2 templates, you don't have to call it templates. You can call it whatever you want, but I like to call it templates so that when people are looking at the configuration, they know that the files inside this folder are templates. The nice thing about templates is they could be whatever you want. We could do just put a generic banner in there and call it a template. Generally, template, when I use it, means that it's a Jinja 2 set of templates. And inside this template folder, we're going to call it natconfig.j2. And you can see that we get this little icon here. This is the Jinja 2 icon, and I'm using an extension within Visual Studio Code that allows me to get the syntax highlighting for Jinja, which is super nice, and we'll see it when I start typing into this file, what's variables, what's for loops, things like that. But the cool thing about a template is it doesn't have to be anything more than just configuration. I always tell people that when you boot up a device for the first time, when you boot up a switch or a router or whatever, the running configuration that's sitting there could be your template. You could just take that and use it bare bones as a template. So what do I mean by that? So I'm just going to put some random text in here. I'm going to set up our NAT configuration. We're going to do interface, gigabit, Ethernet 1. And then I'm going to come over and I'm going to do IP NAT outside. And I'm going to do interface, gigabit, Ethernet 2. I'm going to do IP NAT inside. And then I am going to set up a rule of IP NAT inside source list 10, which is going to be an access list that we haven't defined yet. Interface, gigabit, Ethernet 1, overload. And we're going to do our IP access list standard 10. 10 permit. Put our IP address in there, 1020. I should say subnet of 0, and then our prefix mask of 255. And then we'll do 20 permit, 10, 1, 30, 0. This is nothing more than the configuration you would have put onto a Cisco device. But this is also a template. Now, you're probably thinking, well, this isn't much of a template. I could have just done this in a CLI. And you're absolutely right. We could take this configuration now, and we're going to take this configuration in a second and apply it to the device. But I'm not going to do it before I make a couple changes. The really cool thing about Jinja templates is that we can do variables from our host vars, and we can substitute out things so that we apply variables that are within our Ansible host vars, group vars, and use them within the template. So how can we do that? Well, I've already got interfaces defined. I have a gigabit 1 and a gigabit 2. What I don't have here is a NAT variable to say what's inside, what's outside. So what we're going to do is we're going to add a variable, and we're going to call it outside. And then we're going to do one here called inside. Now you're probably thinking, well, you've got these variables here now, isn't that going to break other things? And no, because we don't use those variables anywhere else. This is strictly for this specific set of configuration. So the other files will ignore this variable because they're not being used anywhere. So here we'll go back. We've got our interface now. And what I'm going to do is to do a loop. You do a curly bracket %, and you type 4. And we're going to say for int in interfaces. What I'm going to do here is I'm going to delete this interface gigabit 1. So our for loop is going to go for interface int, and we need double curly brackets, int dot name. Because if we go back, interfaces name gigabit 1, we're saying for interface in interfaces. So for each item in the list, let's go through them and loop through it. We're going to get int.name, which is saying for each int being the interface, for each value in the list. So we'll start with int.name. We'll do int name. And then what I want to do is say if int.name equals gigabit Ethernet 1, we do IPNAT, and we do int.nat. And then we can do another one we can do elif. So else if int.name is gigabit Ethernet 2, IPNet will be int.net. So what I've done here is I have a single line that says loop through these interfaces. It'll loop through the interfaces and it will look at int.name, and I only have to apply this once. But what I'm now saying is let's do a check. Let's check the value so we can determine which NAT statement we want to apply. I could have just as easily done interface int.name, and then I could have done IPNet because we know the order. But what if your order was different? What if gigabit 1 was your inside interface, gigabit 2 was your outside interface? Or what if you wanted to have some control over, which interface was applied where, when, how? What I want to do here is basically have it set so that it's just like the configuration of the device. Here, we're doing a loop through the interface. We're saying interface int.name, which is getting gigabit 1. We're saying if that interface.name equals gigabit 1, or whatever we want to look for, apply that NAT configuration. And then if the interface name is gig.2, then apply its configuration. If we were looping through several different interfaces, like we only got 2 here, but what if we had 10? What if we were looking for, hey, if the interface equals gigabit 3 or gigabit 7, that's when I want you to look through this statement and apply the IPNet that's underneath of it. Same with this interface here. I could apply the IPNet that's under it, depending on where it is in the order of operations. So it just gives you some flexibility as you're running through your interfaces to see when to apply certain values if you want to apply them. And if not, just skip it. Like, we don't care if this is gigabit 3, 4, 5, 6, or 7. I'm only interested in doing these lines if it's gigabit 1 or gigabit 2. So here we need to come down and we need to do an end for. Actually, we need to do an end if. And this closes out this entire if bracket. And then we need to do end for. And that'll close out the for loop. So now we've got this IPNet source list inside, and we've got this access list. Well, one way we could make this better is to come here now and let's do nat config. And what we're going to do is we're going to create a name, and this is going to be the access list name. So I'm going to call it 10. I'm going to say interface to define the interface that's my outside interface. And then I'm going to do a rules. And this is going to be another list. We're going to go back here and I'm going to take this line here. Actually, I'm going to just take both these lines now. Paste it. And so what I have here now is the NAT configuration. We're going to go back to our Jinja template and apply. We'll be able to use 10 for the access list name. We'll be able to define our interface. And then we'll have the rules print out as a list. So here we go. We've got our IPNet translation here. We're going to change this. Actually, we're going to do a for loop. For NAT in NAT config. And so what I want to do now is I want to come through here and I want to say, so our source list is going to be nat.name. Our interface is going to be nat.interface. And then here, we'll do nat.name again. And then underneath of this, we're going to do another for loop. Because this is nested inside the top level of nat config, we're going to do a for rule in rules. Actually, it's going to be nat.rules. So this is saying we're looping through nat, the options inside nat config. We're applying our source list, net.name, interface, net.interface. And then we're going to do our IP access list, standard net.name, which is going to be 10. But we're saying for rule in nat.rule. So we're still within this for loop here. We're looking at the rules now. And we're just going to come here and we're going to do 2 curly brackets and we're going to type rule. And that's it. We're going to do a %n4%. And then we're going to do one more. So this one closes this for loop. This one closes this for loop. Now, you're probably looking at this going, well, that's a lot of extra lines for configuring NAT. You didn't have to do all that. You already had that NAT configuration. But the cool thing about this is that it's flexible now. This could be any interface. I could modify this, for whatever I'm trying to look for. It's kind of up to you, and it shows you the versatility of building templates. There are tons of options when you start building your templates. You can do macros. You can do a lot of different things with for loops, if statements. You can create a lot of complexity and really check for a lot of things as you're building out your configuration. You can also make them super simple, as I showed at the very beginning, where we just had a bunch of configuration statements in. We could take in it and applied it. So what I'm going to do now is we're going to save this file. We're going to come back and we're going to do another new file. And we're going to call this nat deploy.yaml. This will be our actual Ansible playbook. We'll do hosts all. We'll do gather underscore facts false. Come down to our tasks. Now what I want to do is I want to create a test file here. We're going to do name test template configuration. Like I've mentioned in all the previous videos, testing what you work with and build is very important before you actually just push it out to the device. So what we're going to do here is we're actually going to test the configuration. We're going to write it to a file and make sure that all the variables apply, that there's no errors, and we're going to get everything kind of tested and validated before we actually decide to deploy it to our device. So what I want to do is we'll do name. We're going to do ansible.builtin.template. And then we're going to define a source, which can be ./templates/netconfig.j2. Destination, we'll do ./net-final.config. And that's it. All we're doing is saying, read this NAT configuration file, look at the destination, we'll write it to this destination. The only thing we want to do here is say when Ansible underscore hostname or Ansible. Yeah, let's try host. CAKV-internet. I think that's the right when statement. So we should be able to go in here now and do nat config. We'll do ansible-playbook nat deploy.yaml. I don't think that's right. Oh, inventory host name. When inventory host name. So we see there was a change. Nothing happened with 9kV because it was skipped. We do have a config file, but take a look at this. This is super awesome. All that really complex, for loop if we come and look at the configuration, we can see the interface, gigabit Ethernet 1, NAT outside, gigabit Ethernet 2, NAT inside. We've got our source of 10. We've got our interface for doing our NAT translation. We've got our IP access rules. this will apply to the device. This will actually configure our device. And now what we can do is take and modify that YAML file, our playbook, and we can actually tell it, let's use the template. We know it works. We know it's valid. Let's go ahead and make sure it applies to the device and works. So let's take a look at building out that playbook now so we have our modules. Okay, so we can go back to our Ansible playbook. And what we're going to do is we're going to look here real quick at Ansible-doc. And we're going to look at iOS or cisco.ios.ios_config. And we're going to space through because there's an example in here that shows how to use it with a template. Here we go. It says render a Jinja 2 template onto an iOS device. So what we want to do is we want to take the template and we want to use this configuration here and set our host up with our Jinja 2 template configuration. So what I'm going to do is I'm going to highlight this, and you can see how super simple this is. Do a paste. I'm not going to do a backup. Just going to do our source of ./templates/nat_config.j2. And for now, that's all we're going to do. But we're going to change the name of this to render Jinja 2 template for NAT onto device. So the main role of this task right now is to just get our NAT configuration done. And we will quit. We've got our files saved. We'll do Ansible-playbook natdeploy.yaml. We'll log in with our user of netadmin and do a -k so we can put in our password. And this should work. And we can see there's something very important I want to talk about in terms of things that you need to be aware of when you're working for your Jinja template, but it says it changed and applied the configuration to the device. So before I talk about the thing I was going to talk about, let's log into our Ansible host. We'll do a show run. Okay, and we see interface gigabit 1 has all this configuration done, but it most importantly has IPNet outside configured. Same with gigabit 2, has IPNet inside created. If we space down, we can see our NAT translation is set up with the source list of 10 and our overload interface of gigabit 1. And then we've got our access list that defined the SVIs that we want to be able to route out. So NAT's configured. Like, we just wrote all this stuff into this template. NAT's configured. At this point, it would just be a matter of testing our configurations, which will require us to have routes so that the devices can get where they need to go. And to do that, I'm going to do one quick thing. We're going to log out. So I mentioned there was something important here. You see this warning that says to ensure idempotency and correct diff, the endpoint and configuration lines should be similar to how they appear if present in the running config on device, including the indentation. So when we wrote that file, you noticed I made sure that there was a space for IPNet and for these rules, because that's how they're rendered in the device. If we scroll back down and look at the configuration, we can see that there's one space for NAT outside, NAT inside. Our translation is not, there's no space, just like it is here. Our access list does have a space. I should be able to do a check on this now. And it should say okay. If everything's right, it should say okay because everything's in the correct order. We see that it is. If I go to apply this again, it should say everything's okay. And so nothing's changed here. that's one of the really important things about working with Jinja templates is you have to make sure that the way things would show up in the configuration, the order of which they would show in the configuration, matches what you put into the template. Otherwise, if I were to pull this space out for, let's go back here, let's remove this space for the IPNAT. This should start throwing a prompt that, hey, something's changed. Now, the obvious is I obviously moved that space, so it's going to error out anyway. So let's just do the change. Nothing has really changed, but we see it failed because it says there's an incomplete command here. Let's see. For some reason, it didn't like that. So I'm going to go ahead and I'm going to do space again. I'm going to change the rule. I think because it's pushed back here, it's treating it maybe as a top level config item. So we'll leave that there. We'll move rule back a space. Okay, we're getting the same thing here. So now it's not rendering at all, and not really sure what is happening here. We could probably add some verbosity to see if it's telling us why it's having issues. Yeah, so it seems to think that this is happening at the top level config now as opposed to within the IP access. So let's go back. Space. Okay, so let's do this. Let's come back here. And so we got these rules. Let's do 20. Let's do a dash 15 permit. And this might not do anything. I just want to see if it's going to come back with a change, but I want to see if this throws the order off. All right, so we see there was a change. It updated, it added 15. We see, okay, so it says it's okay, even though the order is wrong. So this is saying 10, 20, 30. It's not throwing the error that I would have expected to say that there was a change, but it could just be something about the way this access list is going in. But in general, like, you wouldn't want to come back here. We want to have a full interface configuration here. We needed to make sure that it matches, so we wouldn't want to take what's sitting on the device for the full interface config and have stuff out of order, because that can cause problems with idempotency. And it's just one of the things you want to be aware of when you're working with your Jinja templates. So, all right, so we've got our configuration done. We're going to come back to our deploy, and we're going to do two more things. We're going to do nat name, configure, routing on iOS or CAT-AKB internet. And we're going to do another one for configure routing on N9KB-switch 1. And so we'll come down here, we'll do a Ansible -doc-L. And what we're looking for is creating static routes. And we're not going to put anything into the variables on this one. We're going to do everything right inside the module. Need a slash. There we go. So if we want to set up static routes, it's Cisco iOS _static routes. And we're going to just check and see what the NXOS version is. I would suspect it's probably static routes as well. And it is. So we're going to copy that. We'll paste it. ios underscore static routes. Put our colons there. All right, and so let's do an Ansible -doc cisco.ios underscore static underscore routes. So we can come down here. We can see that we do configuration lines. So we're going to come here, do 2 spaces in config. We don't have a verf. We just have routes. So we're going to do routes. Just take a quick look at this. Yeah, so it looks like we need to tell it whether it's IPv4 or not. Well, that looks like that's for a verf, though. We don't want the verf. Let's see. Okay, so it looks like we want address families. So we'll do 2 spaces address families. AFI is going to be IPv4 because that's the address family. And then we're going to do routes. And our route for the cat AKV, we want a destination of 10.1, 1.20.0, 255, /24. The next hop is going to be the remote end of the nexus. So let's log into the device real quick. So let's see, we're 254 here. We should be 253 on the nexus. So I'll do 192.168.100.253. And that's it. So 253 is going to be our next hop. And then we'll do another destination of 30 to the same hop. So this will say when traffic comes back, if it's destined for 10.20 or 10.30 or 10.130 or 10.120, the next hop is going to be the Nexus device. For our Nexus, we just want a default route out. We don't need anything crazy. So it should be as simple as saying, assuming that the rules are the same, we'll just look to see if there's an option for a default all zeros route. Doesn't look like there is. So what we're just going to do is we're going to take this because it looks basically the same. Take all this. And we'll say 0000/0 to 254. And that should do it. The last thing to do will be, and because we're doing very specific host configurations, this isn't a matter of when it's NXOS or when it's iOS. We want to make sure that when it's Cat AKV Internet or it's N9KV-SW1, these rules apply at that point. So let's quit out of here. If we've done everything correctly, we should be able to do our playbook. We'll do a - check to make sure there's no errors. Again, this is just good to make sure that what you apply is actually going to work. You see that it failed because we missed something. So it's saying next hops. And it's possible I did not type that in right. Yeah, so it's next hops. S2. Yeah, it's next hops. So we'll do next hops. It looks like we need to do a list of for router address. We'll do the same thing here. Save that. And then this should probably be the same thing for router address. All right. So now we can try it again. Again, it's always good to check your configurations, because if we had more going on in this playbook, it could break a lot of subsequent things, or if we had other stuff going that wasn't just these route tables, things might run, then the configuration's just completely out of sorts, and this way you know what you've applied or what you've created should work on the device. You can run it and then start making your changes. So it looks like we're good now. We can do our password. This should apply to the device, and after this, we should be able to go look at our hosts and log into them and get out to the internet. So we see 8KB internet's changed, Nexus 9K's changed. We'll just log in and check. So here we go. We're on the router. I jumped. Show IP route. You can see we've got an all zeros out to our NAT. And then we've got a route to the Nexus for 10.120, 10.130. We should be able to go over to our Nexus now. And we see we have an all zeros to 254. So this means that we should be able to go over to our host now and get out to the internet. So let's go over and take a look at them. So go back to CML. We'll go to our VLAN 20 host. We'll console into it. We'll do net. Make sure that's the right username. Check config. Cisco. All right, so we're logged in. We should be able to ping all the way out to Google now. And we're doing a ping 8.8.8, and we can see we're getting a response. So this is going out to the internet. Well, how can I prove that? Really easy way. Let's do a packet capture. And we're going to run it. And what's interesting here is what you should see is that our source address is actually the NAT IP address, or the DHCP address that's assigned to our NAT outside. So we're translating 221 to 8.8, or translating our inside or whatever it is, so we get to 8.8.8. If we come over here and we look at this packet capture, we can see 10.1.2100 is going 8.8.8. It then gets translated to 192.168.255.221 to get out to our host. So we can see that the NAT translation is working there. We can come over here now. We can do the same thing. But one thing I'm going to do is I'm going to do a sudo vi etc resolve.conf. Now resolve.conf on Linux is the where you set up your name server so you can get out the DNS. What I'm going to do is I'm just going to do name server 8.8.8. And that's just going to say use Google to do my NS lookup. It should be able to do google.com now. And we can see that we're getting out to the internet to do DNS lookups. So what else could I do? Well, one thing I found recently is you would do a speed test, and you can actually download. So we do EPK install speed test CLI. Let's see, get APK minus help. Oh, it's APK add. Do an APK add. And you see we're pulling from the Alpine package repositories, and we're installing the speed test tool. And now what I'm going to do is I'm going to do a speed test. can see that it's going out and it's doing a download from a server out on the internet. And while this is not going to be incredibly fast, because CML doesn't have a huge pipe for network traffic, it is going to get us out to the internet to do a lot of different things and demonstrate that yes, we are absolutely going out. We're absolutely doing packet captures from the real world. I can come back over here. We'll do our VLAN 20 host. So let's do sudo apk add do Python. Let's try that again. So we can see, I had to find something that would actually go out on. So we can see it's going out to cdn.alpinelinux.org. It's going out and it's actually downloading all of those files now using our NAT translation. With CML, we have the built-in packet capture, so we can actually start taking a look at this. If we want to get more info about what's happening behind the scenes, we can see our NAT translation here. We can see that it is going out to get this set of packages that I asked it to pull, and it's almost done now. And the capture's done. It was really fast. We're only pulling 50 packets. You can actually come to settings and you can set that higher. But ultimately, this demonstrates a couple things. One, we have provided full network connectivity now, as promised, through our CML hosts. So these two hosts here route to switch 1. They have a default route to the next hop of CAT-AKV internet. Because we want them to go to the internet, if the packages match and they're destined for something that's not local to this router, they get punted to the NAT external connector, which you can see again running NAT. Go out to the internet through my home internet, and then they come back. When they hit this router, because we have a static route for 20.250 for 20.0 and 30.0, they route back to the Nexus and then get sent back to the respective hosts. And again, we've got Google ping, we've got DNS lookup. We just installed 2 sets of packages. We did a speed test, so we actually go out somewhere to do something. We could just do one more. We could do a wget to https://cisco.com, and it will say no check certificate. And it should download the index from cisco.com. Oh, this was the wrong one to do it on because I don't have DNS set up. But we pulled down cisco.com. So it is getting out to the internet. It is pulling stuff down. We can see that it went out to whatever Cisco's public IPs are. Went to 443 because they said HTTPS. And so, yeah, like we've done everything now. I've demonstrated to you how you can use Ansible in a lot of different ways, how to work with show commands, how to set up basic system config, how to start working with your interfaces, how to use Jinja now, how to work with scenarios, in this case where the module doesn't exist. We don't have NAT modules, so you need to kind of build your own template to do that. We could have just as easily done everything we did today. Go back to Visual Studio Code here real quick. We could have just as easily done everything inside this template. I could have done the static route here for the CAT-AKV. I could have created another template for the Nexus and just done the static route there and then applied it using the NXOS config. We could have done that. But I wanted to show you kind of just the versatility and capability that Jinja templates give you. I also wanted to show you, not everything has to be done in a variable. For static routes, we added these couple routes here. You generally don't add them everywhere. You might just have a playbook for routes where you manage all the different routes on a device. You can still control it with when, and say, if it's the inventory host name of my such and such router. In this case, it's CAKV Internet. Same with this Nexus. But where we don't have static routes, it's just one less thing that has to be done in our variables. We can kind of control it just within the playbook itself. So I hope this has been valuable. This is going to wrap up, like I said, the network automation series on this specific network automation lab. Where we're going to go now is we're going to take and I'm going to push all this stuff out to GitHub. So you'll have access to it with the updates. And then we're going to start looking at other things. I'm going to do a new lab. We're going to look at RESTconf next. And I'm going to show you how it's not too dissimilar from looking at the running config on a device, at least with an iOS XE device. And we'll take a look at how to do configurations there with RESTconf and start working with Postman. I'm really excited now to kind of be moving into the next phase of showing you some automation stuff. So if there's anything you want to see, like, leave me a comment. I'll definitely try to put some material together around it. The RESTconf video I'm going to start working on pretty soon, so I'm looking forward to share that with you. And again, I hope this is helpful. If you have anything you want to see, please let me know and leave me feedback in the comments. Thanks for watching.